Alright, so I've got 4 capacitors in a network. There's a 1 farad, 2 farad, 3 farad, and 4 farad. And I want to simplify this to find out what is the equivalent capacitance and what charge is on each of these capacitors. Let's say that the delta V from A to B is 10 volts. So I'll call B 0 volts, and then A could be at plus 10 volts. Alright, so first thing, we want to look for capacitors which are either wired directly in series or directly in parallel. So I see that these 2 capacitors jump out to me as being clearly in a series. They're in a series. So I want to combine them, and we'll make a new picture, and we'll have that. This can be called C12, which is the combination of capacitors 1 and 2. And I gotta find out what that equivalent capacitance is. So the rule for capacitors is 1 over C1 plus 1 over C2. That'll be okay, so that's going to be 2/3 farad. At that point, we want to go to the next step, which is to look for capacitors which are directly in series or directly in parallel again. And these 2 stand out to me as being wired in parallel. So I'd like to combine them into one capacitor. And we're just trying to get closer and closer to having just a single capacitor to represent the whole network. This could be called C123 perhaps, and this is C4. Now the rule for parallel capacitors is we have to add their capacitances. So we'll have C12 plus C3. That's going to be 2/3 plus 3 . (11/3 farad). Alright, lastly, I'm going to combine these 2, which are in series. And now we got it down to just one capacitor, which I'll call CEQ. So just following the series rule, CEQ is going to be 1 over C123 plus 1 over C4. That's 1 over 11/3 plus 1 over 4 about 1.91 farads. Yeah. Okay. Now I'd want to work my way backwards. I want to figure out how much charge is leaving the source and how much charge is going on to this imaginary capacitor. So for that, we'd use the formula Q that's leaving the source, will equal CEQ times the delta V total. Alright, so that's going to be 1.91. Yeah, 1.913 farads times 10 volts. Talking about 19.13 coulombs total. So 19.13 coulombs going on to that single capacitor. Now we can work our way backwards to reason out what charge goes on each of the individual capacitors. So because these are in series in the previous diagram, they have to have the same charge on them. So that means the charge over here, Q4, has got to be 19.13, and the charge on 1, 2, 3 has to be 19.13. So now when we go back to the previous diagram, the charge on capacitor 4 we already determined was 19.13. But what we find about the other capacitors is they will share 19.13. Q12 plus Q3 equals 19.13. Alright, some of the charge will go on the upper capacitor, some of it will go on the lower capacitor, and we don't know how much yet until we find the voltage that those capacitors will hold. So how can we find the voltage? Well, we know in our second to last picture what the charge of Q4 is. We know what the capacitance of Q4 is, so we can find the voltage drop across C4. So I'll just do that on the side here. We can use C4 equals Q4 over delta V4. Plug in what we know. 4 farads equals 19.13 coulombs over delta V4. So delta V4 must be 4.782 volts. And we also know another fact. We know that the delta V of 1, 2, 3 plus the delta V of 4 has to equal 10. Why do we know that? Because we're going from 0 volts up to 10 volts. We have to go through these two elements, so we have to have a 10 volt change in that path. So since delta V1, 2, 3 plus delta V4 equals 10 volts, we can plug this in. And solve. So the voltage drops then are 4.782 here and 5.217 here. Now that's going to carry over to the previous picture as well. This capacitor drops 4.782 volts. And these guys, because they're in parallel, they'll drop the same amount. They'll both drop 5.217 volts. Now what we can do is we can use their voltage drops and their capacitances to find out how much charge is on each of them. So we have C3 equals Q3 over delta V3. That's going to be 3 farads equals Q3 over 5.217 volts. I get 15.65. coulombs. Okay, now we know Q3. So can we find the charge that's on the upper capacitor? Yeah, we could just do the same kind of calculation. We could do C12 equals Q12 over delta V12. That would be fine. So 2/3 farad equals Q12 over 5.217 volts. I get 3.478 coulombs. And you just want to check that the Q12 plus Q3 really adds up to 19.13. Lastly, we would want to give our final answer for the overall problem. So we've got 19.13 coulombs on this capacitor. We've got 15.65 coulombs on this capacitor, and C1 and C2, they would share the same amount of charge because they're in series. 3.478 coulombs there, and 3.478 coulombs there.